Hello everyone, welcome back to our channel. We were discussing about relations in functions, class 11th Maths ncert. We'll continue with it. We'll discuss some standard functions and their respective graphs in this class. The first one is identity function. As the name suggests, that it is related to the word identical. Sorry, one second. Yeah. Identical. We know that any standard function from set A to set B is defined as a set of all x, y such that x belongs to A and y belongs to B. Here, for any relation to B function, your first A should be domain. And set B is by default your codomain. Also, there is always a relation between this x and y. So, you can write y as a function of x. Y is equal to f of x. Thereby, transforming this definition of f as something like x, f of x, such that, and so on. Hope this is understood. This was just a recall of what we studied in the last class. Now, based on this idea, we'll build up some standard functions. First one is identical function, which means that whatever value of x you place in your formula, you have y is equals to f of x. So whatever value of x you place over here, you get the same value over here. So for x is equals to 1, you should get y is equals to 1. For x is equals to 2, y is equals to 2. Which means this itself becomes equal to x. So you can write it like y is equals to x or f of x is equals to x. Both mean the same. Here, you can plot this on a graph. At x is equals to 1, you get the value 1, y is equals to 1. At x is equals to 2, y is equals to 2. At x is equals to 3, y is equals to 3. In short, if you place all these points over here, or for all values of x, you'll get all values of y. So let's consider x to be real. That means you're considering every value on this number line. R represents your domain, and this R represents what you're getting. So we'll come to the second R later. The first R is the value of x, all the values of x that you can place, or this is your domain. When you place these values of x in your formula, in your function, y is equals to x, for all these values of x, you get the same values of y. So you end up getting a straight line passing through the origin in your graph. These points will lie this 1, 1, 1, 2, 2, 2, 3, 3. These points will lie on this particular line. Since x is equals to real values, the y will also be equal to real values. This is your codomain. So whenever someone asks you what is an identical function, all you have to say is y is equals to x. But you should remember what is your domain, what is your codomain, and what is this graph. What will its graph look like? Now the function y is function such that r to r means both are real. It means your domain and codomain both are real. This type of function is also called as real valued function. So this is real valued function. For simplicity, we'll consider every function over here as real valued. Next, second type is constant function. Now again, the name itself states that something is to be constant. Now, we are considering y is equals to constant. We are considering y is equals to constant. Let's see, denote that particular constant. C can hold any value, but this is one equation. For one equation, C will have only a single value. Or for one particular value of C, you'll get one particular graph. So for C is equals to, say, 2. Your y value is stuck at 2. That means y is equals to C or y is equals to 2. Y can be written as f of x is equals to 2. If you place any value over here, if you formulate a table and place any value over here for x, you'll always get the value C, which is 2. For x is equals to 1, f of x is 2. For x is equals to 2, f of x is 2. For x is equals to 3, f of x is 2, and so on. No matter what value of x you place over here, you'll always end up with 2. So, its graph would look like a straight line passing through y value 2. Why y value 2? Because f of x is 2. That means y is always 2. Y is always 2. So it should be a straight line passing to 2. All these points 1, 2, 2, 2, 3, 2, they can be found on this particular line. So your function is a constant function. You get a straight line parallel to x-axis, which is never touching the x-axis, and your y is equals to constant. Observe in both these scenarios, the x value, your domain, lies on x-axis. The values of domain, they lie on the x-axis, and f of x is equals to y, and this y is represented over here. So this y-axis means your codomain. Range, on the other hand, would be all those values. Range would be all those values of y for which you are all those values of y that you get when you place every value of your domain, that is x, in that particular formula. So for this particular value, for this particular constant function, we started with a function where you took real values as your domain, but ultimately, and your codomain is also real, but your range over here in this scenario is only C. In this particular example, only 2. Here, R is your domain and R is your codomain. But what is your range? Range will also be equal to R. Why R? Because all the values of x are being attained in y. In the second scenario, your domain is all the values of x, so your domain is real, but your range is just 2. In general, your range is C. Codomain would be all the possible values of y that you could get, and actual range is the value of y that you get after placing all the values of x. So the image of these x is your range. Next type of function is polynomial function. Now there can be infinite functions over here. We'll discuss only 2, quadratic and cubic. A polynomial function, for a polynomial function as well, let's consider your domain and codomain to be real. The domain and codomain. A polynomial function is defined as y is equals to f of x is equals to a0 plus a1x plus a2x square plus n dot dot till an x to the power n, where this n is supposed to be a positive integer. integers, z is the symbol used to define a set of integers. So n has to be a positive integer or 0. So n has to be a non-negative integer. So the minimum value of n that you can have is 0 and the maximum value is infinity, thereby giving you a lot of polynomial functions. a0, a1, a2, till an, which are the coefficients of each term, has to be any real value, or they should belong to R. Now, we know that for a constant function, you won't get any, for a constant function, you'll get a line parallel to x-axis. This is a constant function. For a linear function, you'll get a line. That means the graph will touch the x-axis at one particular point. Looking at the same thing from another perspective, linear function itself says that it would be a line. It may be an identical function or not, but it would be a straight line throughout your plane. For y is equals to f of x is equals to x squared, this is an example of quadratic function because you have an x squared term. Now let's solve it practically. Let's try to draw the graph of it practically. So we'll consider certain values of x and we'll try and attain certain values of y, and then we'll plot it on the graph the way that we usually do for equations since 8th standard. So let's consider certain values of x and to obtain certain values of f of x. So at x is equals to 1, your y is equals to 1. 1 squared is 1. At x is equals to 2, y squared, x squared is equals to 4. X is equals to minus 2, x squared is 4. X is equals to minus 1, again 1, and at 0 you get 0. Similarly at 3 you get 9. At minus 3, you again get the same 9. If you plot these points, you'll get for 1 you're getting 1. For 2 you're getting 4. Similarly, 1 and then you're getting 4. If you plot these, you should get something like this. A curve. Okay? A parabolic curve. The name isn't relevant now, as of now. It's just informative. But you should be able to define the function by observing this particular curve. So how will you define the function and what kind of domain and range will you get? Your f of x over here, let's divide it into two parts. For x greater than equals to 0, your f of x is positive. And for x less than equals to 0, f of x is again positive. No matter what value of x you place, you get y value always as positive. This is something that you should understand from it. This is the expression, the curve for y is equals to x squared. What is the domain and range? You can place infinite values of x over here. So your domain is equals to R, a real value. What would be your range? And what would be your codomain? Again, you can, for these infinite values of R, you should get values of R which are only positive in nature. So no matter what value of R you place, positive or negative for x, you always get a positive value for y. So in short, you can say that your range is positive R positive, a positive value for R. Range means by values that you're obtaining, that you're attaining. R plus. What is your codomain? Now, codomain can be anything. It can be either R plus or R. Next is your cubic polynomial. Now, cubic polynomial, we know it's represented by x cubed. We are considering x cubed instead of considering a big cubic polynomial, x cubed minus 2x squared plus 2x plus 1, something like that. We are we prefer to use x cubed, which is the simplistic version, in order to attain the graph. Now, if you go by the same method, we'll end up getting a graph like this. By observation, what is your domain and range? You can try this by drawing a box like the one we did in x square, and then placing the values and then plotting those values and thereby attaining the graph. Such kind of graph system can be done for any quadratic or cubic polynomials. It's a little tedious, but it will help you get a good handle over the concept or the drawing part of it. Domain. Y is equals to x square. You can place any value of x over here. So this is a real value. Range. If you place positive values of x, you get positive values of y till infinity. If you place negative values of x, you get negative values of y till infinity. So range is also equals to R, unlike the one that we have earlier. You can define the domain and range in set builder form as well, instead of just writing it in the form of sets. These are standard sets that you're defining it as. For example, here, in the previous question, domain name, you can write it something like a set of all x such that x belongs to R. Range can be written as set of all x square such that x belongs to R. You're not discussing x square because x square value will always be R positive. But for any value of x, whatever value of x square you get is your range. R plus is the generalized way to define it. Similarly, this function in general can be defined as y is equals to an ordered pair of x comma x cube, because f of x, x comma f of x is x cube. So x comma x cube such that x belongs to R. Similarly, this domain can be defined as a set of all x such that x belongs to R, and range is a set of all x cube such that x belongs to R. You can have biquadratic function where your power of x is 4 or so forth. You can try the graphs for any value of the function, say x to the power 4 or x to the power 4 plus 1 and so on. Next type of function is rational function. Now, rational function, the name suggests that it should have a function in the numerator and it should have a function in the denominator. To avoid confusion, let's place g of x upon h of x. Here, the only condition is your h of x should never be equal to 0. Otherwise, the answer would be infinity or not defined. So rational functions is a ratio. Rational means rational numbers are those numbers which can be represented in p by q form. So rational functions will also be those functions which can be represented in p of x upon q of x form. Now, to understand rational functions, let's consider an example of rational functions. So let's consider a fraction. We are considering the fraction as 1 by 2. So f of x is equals to 1 by 2. Here, the condition by default becomes that x cannot be equal to 0. So x can hold any value except for 0. This means your domain should be equal to a set of all R except minus a set of a 0 value. So here you have used the operation difference to remove or discard 0 from the real set. So you can have any value except for 0, subtracting 0 from it. This is your domain. Now for any of these values, let's see what value of f of x we get. At x is equals to say 1, you'll get 1 upon 1, which is this. At x is equals to 2, what will you get? You'll get 1 by 2, which is a value smaller than this. At x is equals to 3, you'll get 1 by 3. At x is equals to 4, you'll get 1 by 4. At x is equals to values smaller than 1, say half. For x is equals to 1 by 2, we'll get f of x as 2. For x is equals to 1 by 3, it is 1 by 3 inverse, or 1 upon 1 by 3, which is equals to 3. So this value of f of x is increasing as you decrease the value of x. In short, we'll end up with a graph like this. What happens to the values less than x? For x is equals to minus 1, your f of x is minus 1. For x is equals to minus 2, f of x is smaller than that. So again, there's a drooping graph. And for values from minus 1 to 0, we'll get incrementing values of y. So as you can see, you can have any value of x except for the 0, because at 0, you'll get an undefined value. And as well as y, for y, you get, for all these values of x, you get all the values of y except for 0. You never get a value 0. For no value of x do you get the value of y as 0. So for our function, for this particular problem, your f of x, function, right? Function is pointing from r minus 0, your domain, to real values. But what is your range? The range is r minus 0. Domain, codomain, and range. Next function is modulus function. Next function is modulus function. In modulus function is a special type of function which is defined as f of x is equals to mod x. Now we know that mod of any value means irrespective of what value you place over here, you'll always get a positive value. So if you place minus 2, you'll get 2. If you place plus 2, you'll get 2. If you place 0, you'll get 0. So modulus means converting a number into positive value, converting one value into its positive form. That is the meaning of modulus. Here also, in this particular function, we'll consider your domain as a real value and your codomain itself as well as a real value. Defined by f of x is equals to mod x. An elaborate form for x greater than equals to 0. For x greater than equals to 0 means for all the values which are positive and 0, your f of x is x. For all the values which are negative, so say your x is equals to minus 1, your f of x is minus x, which means it is minus of minus 1, which means positive x. This is an explanation of this mod x. So if you can write this as f of x is equals to mod x, or in elaborate form, you can write it like this. The second form is helpful for you to plot the values on the graph. Now, on the graph, let's plot the values. For x is equals to 1, you'll get y is equals to 1, x is equals to 2, y is equals to 2, x is equals to 3, y is equals to 3. So you're getting a positive line starting from 0, because for x is equals to 0, you'll get y is equals to 0. Now, on the negative side of x, for x is equals to minus 1, your y will be equal to plus 1. For x is equals to minus 2, y is equals to plus 2. Even if you place negative values, your y is always positive. Y is always positive. So this is a graph. This is the graph of modulus function. Let's understand the domain and let's understand range. Now for any value of x, positive or negative, your y value is always positive. So here also, like parabolic function, your range will be equal to r plus or positive value of r. You can also say that your range will always be non-negative, because by calling it positive, you're excluding the fact that range can also be 0. So either you can add 0 to it. The same can be done for the previous value, r plus 0, because 0 is neither positive nor negative, and you can get a value of 0 as your range, as a value of y. So either you can write it like this, or range is always non-negative, all non-negative numbers. This by default is your domain, and this is your codomain. Now we are left with one more function, which is your signum function, and some algebron functions in this chapter. So let's cover that in the next class. Thank you.